So the last two times that I tried this, whenever the last four times, whenever I've started at the first slide, it's been a single big slide, and whenever I've started at a slide in the middle of the show, it's been a small slide. Now it doesn't always work that way, but it has the last couple times. And if I hit swap displays, sometimes it corrects that. So I'm going to take a chance and hit swap displays. So let's factor with a lead coefficient other than 1. And the first test you're always going to take is you're going to ask yourself, is there a common factor? Is there something that they all share in common? And for number 8 here, there's not, because 2 does not divide into 2, 5, and 2. It doesn't divide into the 5. So whenever there's no common factor, what you're going to do is take the first term and multiply it by the last term, okay? And that changes the whole new question. You get rid of the 2, you multiply it at the end here, and you get x squared minus 5x plus 4. Then you factor that exactly the way you did before. You can use either the AM technique or the graphing calculator technique. It makes no difference, and when you're done with that, you're going to get x minus 1 times x minus 4. Now, if I was a student sitting in class and my teacher did this, my hand would shoot up so fast and I would say, so let me get this right. You give me this really hard question that has a 2 in front, and then you change that to a much easier question. I love this. Can I do that on all of the questions I don't understand? And the answer is not really. See, I multiplied by 2 the last term. Now, to compensate for that multiplication, we have to divide back by 2. Think about it this way. Pick your favorite number. I'm going to pick it 5. And then I'm going to multiply by 2 and divide by 2. 5 times 2 is 10. Divided by 2 is back to 5. Let's do another number. Let's do 9, and let's do times 5, which is 45, then divide by 5. We get back to 9. Let's do 7 times 10, which is 70, divided by 10, which is back to 7. So the truth is, if you multiply and then divide by the same exact number, you get back where you started with. So since I multiplied that last term by 2 to get the 4, now I'm going to divide back into the last term by 2. So in other words, I multiplied up here and I divide back here. Now, at this stage, if you get a number that you can simplify, like 4 over 2 is 2, you're going to make this x minus 2. And if you cannot get a number that you're going to simplify, do you remember the elementary school trick of like converting between mixed numbers and improper fractions? If you got a term like 1.5, we would say that was 3 over 2, because we would do 2 times the 1 in front plus the 1 up top. That's what we're going to do here. In this case, I'm going to take the 2 here, going to multiply it by the x, and do 2x minus 1. So the final answer here, note the 4 over 2 reduces to 2, so that was easy. But on the left one, we're going to have to multiply that 2 by the x, kind of like elementary school with converting improper to proper and so on and so forth. So 2 times x becomes 2x minus 1. You lose the denominator. So you take the first term, multiply it by the last term, factor as usual. There's my answer. That should be easy. Then the tricky part. If you multiply the last number by 2, you have to divide back in by the 2, both of the terms. Now, if it reduces, like 4 over 2 reduces to 2, reduce it. If it does not reduce, do the elementary school trick. Take that 2, multiply it by the x. So I get 2x minus 1. And that's my factors. Now let's just check it back and make sure it checks. 2x times x is 2x squared. So far, so good. 2x times negative 2 is negative 4x's. Negative 1 times x is negative 1x. If I do negative 4x plus negative 1x, I get negative 5x. Nice. And then negative 1 times negative 2 is positive 2. Okay, let's take a look at number 9. I want you to try it, and I will leave the answers to number 8 up step by step for you to figure it out. Go ahead. Okay. So, first things first. There is no common factor among all of them. I cannot take the 3 out. So I multiply the last term by 3. That gives me, remember, when I multiply by that 3, I eliminate it in the front, x squared minus x minus 6. So, again, I can't factor out the 3, so I just multiply it by the last term. That's where I get the negative 6 from. And because I multiplied it there, I no longer have it in front. Factor as usual, x minus 3x plus 2. But we are not done. If I multiplied by 3, I've got to divide back in by 3. So I'm balancing that multiplication with division. So I divide back in by 3, both of the numbers in the binomials. Now, 3 over 3 is really easy. It reduces to 1. 2 over 3 is not so easy. So what we're going to do is take the 3 and do the elementary school trick. Put it in front of the x, and then I lose my denominator. So that's 3x plus 2. Let's do a quick mental check. Make sure it works. X times 3x is 3x squared. X times 2 is 2x's. Negative 1 times x is negative 3x times 3x, is negative 1x. Is negative 3x. I was a step ahead. 2x and negative 3x make negative 1x. And negative 1 times 2 is negative 2. And if you look at that original equation, ding, 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 that's exactly what we wanted. Okay, try number 10. Again, I will leave the steps up. Okay, so I look to see if 5 divides into every term so I can factor it out. I cannot. So I go to what I call plan B, and that's what this technique is. I call plan B. It's my second option. My first is to try to pull out a greatest common factor. That would be plan A. So I'm going to multiply the last term by the first term, the leading coefficient. So that multiply L by LC means multiply the last by the leading coefficient. I do that, and I get this brand new quadratic or trinomial, n squared instead of x squared, minus 7n minus 30, or x, whatever. And I factor that using the techniques I knew from before today. X minus 10x plus 3. If I multiply by 5, I've got to come back in and balance that out, so I got to divide by 5. Now, 10 over 5 is 2, so I get x minus 2. And the other one can't be reduced, so I go to elementary school trick. 5 times x is 5x plus 3. And those are my factors, x minus 2 times 5x plus 3. Let's distribute back and check myself. X times 5x is 5x squared. So far, so good. X times 3 is 3x's. Negative 2 times 5x is negative 10x's. Negative 10x's and 3x's make negative 7x. Bingo. And negative 2 times 3 is negative 6. Okay. So that's a really good summary of what I call Plan B technique. Okay? All right. So Plan A is always to look for a greatest common factor. Take a look at number 11. See how they have a greatest common factor of 2 in common? And if I factor out that greatest common factor of the lead coefficient, I no longer have a lead coefficient. I factor out the 2, and now I just factor x squared plus 5x plus 4, which should be pretty easy. That comes out to x plus 1 times x plus 4. Just don't forget the 2 in front, okay? So many students forget the 2. It's like they get excited that they got the x plus 1 and the x plus 4 that they forget all about the 2. You need all 3 parts to be given credit for the question. If you don't put the 2 there, you would never get out the 2x or 2n squared. Checking it back, I double distribute first. That would give me x squared plus 5x plus 4. Then I multiply by the 2 in front, and that gives me 2x squared plus 10x plus 8. Okay? Do not forget the 2. The biggest mistake that I have seen over the years is students who forget to include the first thing they factored out. Okay? It kind of slips their mind. Take a look at number 12. There is a lead coefficient. I'll leave the steps up, factor it through. Okay, so lead coefficient of 2, you can factor it out. That means this is plan A. We love this. This is great. We just factor x squared minus 3x minus 40. It gives me x minus 8 and x plus 5. Don't forget that too. If I distribute back, I'm going to get just the binomials, x squared minus 3x minus 40. Then I double that and I get 2x squared, or h whatever, minus 6h minus 80. Looking good. Okay, take a look at number 13. Do you find a greatest common factor there? No. Since there's no greatest common factor, we go to plan B, which is what we learned before about multiplying, taking the lead coefficient, multiplying it by the last term. Go ahead. Remember, this is like the previous slide. It's not like these numbers 11 and 12 on this slide. Okay, so it's definitely a plan B situation. And I'm going to take the 4 in front, multiply the negative 3 by it, and I get x squared plus x minus 12. Factor that business as usual. That would be x plus 4 times x minus 3. Now, because I multiplied by that 4, I've got to divide back in by that 4, balance it out. That gives me x minus 3/4, right? Take the first binomial, divide that last term by 4, and x plus, and then 4 over 4. Now, 4 over 4 reduces to 1. That's nice and easy. You can't reduce the x minus 3/4, so we go to elementary school trick, put the 4 in front, no denominator, 4x minus 3 times 3x plus 1. And if we check back, 4x times x is 4x squared, 4x times 1 is 4x, negative 3 times x is negative 3x. Add those up, you get 1x, and negative 3 times 1 is negative 3. So that is advanced factoring and what you should know. What's the happy recap? First, what is the AM technique? That's when the lead coefficient is 1, and you do what? You check multiply out to the last term, add to the middle term. We have 2 techniques with that. The other one is we use the AM guidance to help us with the graphing calculator. And with the graphing calculator, we do y1 is whatever the last number is divided by x. y2 is that same exact thing as in y1 in parentheses plus x. Then we look for whatever the last term, the middle term is in the last column. The 2 previous columns are the factors. How do you handle factoring a lead coefficient other than 1? Well, we got 2 plans. The first plan is plan A, and in plan A, what we're looking for is a greatest common factor that we can factor out the lead coefficient. If we can factor out that lead coefficient, I just factor it out, and then I factor the trinomial that remains. That's plan A. If that doesn't work, we go to plan B. Plan B is when we take the lead coefficient, multiply it by the last term, factor that, but then divide that lead coefficient back in. You can't forget that. You have to remember to divide that lead coefficient back in. Okay? The plan B stuff is a little tricky at first. Once you get it down pat, you do 5, 6, 7 examples, it's really easy. Just don't forget to divide back in by the lead coefficient. If necessary, maybe go back and look over a few examples of that. Okay? All right. Have a great day.